Hey everybody, how's it going? Today I want to explain to you what a derivative is. Suppose we want to find the slope of this function on the reals over a certain interval. So let's pick one point here, we'll call it x. Here's the output, f of x. Let's pick another point right here. We'll call this x plus h. So we took x here, right here, and we nudged it some distance to the right, h. So that's all this is saying. It's saying, hey, take that original x you had and add a number to it. So this is x plus h. Therefore, our output here is f of x plus h. Perfect. So how do we go about finding the slope of this line? Well, let's remind ourselves how slope is defined. So slope is defined as rise over run, or delta y over delta x, which is just y2 minus y1 over x2 minus x1. This is slope. Okay, let's plug in the points we chose. So I will plug in my y2 is f of x plus h, because that's the y coordinate of the second point we picked. Let's subtract y1, which is f of x. Let's divide this by the difference in our x values, x plus h minus x. Great, so here's our slope. Now, as these 2 points we chose grow closer and closer together, we'll notice that they eventually converge at a single point. So as h grows smaller, as the distance we nudge x in this direction, h, gets smaller and smaller, the 2 points that we chose are going to get closer and closer together until they're basically the same point. So if I wanted to be as accurate as possible and find the slope at any given point in this function, let's allow h to approach 0. So we'll take the limit as h approaches 0. This is just saying, hey, the amount of distance that you nudged x, let's make it so small that it's approaching 0. And we'll call this result f prime of x. So this is our definition of derivative. Let's apply this to an example. Suppose we have a function, f of x, over the reals. Let's say it's x squared. What if I wanted to find the slope at any given point of this function? Hopefully you'll remember that this is just a parabola. Okay, well let's use our definition of derivative to find easily where the slope at any given point will be. So we'll say the limit, make my brush thicker here, we'll say the limit as h approaches 0 of, in this case, f of x plus h is just x plus h all squared. And f of x is x squared. Let's divide this by the difference. Oh yeah, it's also good to mention that x minus x is 0. So these x's here just cancel out, leaving us with h in the denominator. Isn't that convenient? Let's continue to expand this. We'll say the limit as h approaches 0 of x squared plus 2hx plus h squared. I simply expanded this binomial here, minus x squared all over h. Okay, let's continue to simplify this. So hopefully you noticed that x squared and x squared cancel out. So we're left with 2hx plus h squared all over h. Let's continue simplifying. Limit as h approaches 0. So 2hx divided by h is just 2x, and h squared divided by h is just h. Now if we take the limit as h approaches 0, h gets infinitely close to 0. So this constant that we're adding here is practically negligible, reducing this to just 2x. Oh wow, isn't that cool? The derivative of x squared is just 2x. So let's see how this applies to, an actual problem. So let's say we have this function here. It's the one we just took the derivative of, f of x equals x squared. Suppose I wanted to find the slope of this function at when x equals 3. Well, that's just this blue line here, but I don't know the value of that slope. And who wants to waste a bunch of time picking points super close to your target point and evaluating something like 3.1 squared minus 2.9 squared over 0.2. That's just too much writing. It's too much work. Hey, luckily we just took the derivative of this function, so I don't need to do all that work. I don't need to manually write all that out and get infinitely close to this point because the derivative is extremely, extremely accurate to the point where we basically get the value of the slope. So let's plug 3 into our derivative. We get f prime of 3 equals 2 times 3 equals 6. So therefore, the slope of f of x at x equals 3 is 6. And this will work at any point on our function. So if you take a point A and you plug this, and you want to find the slope of this function at A, you just need to plug A into the derivative. And this will be the slope at that point A. Thank you so much for watching, and I hope you have a great day.